Okay, welcome. Good afternoon. I'm excited for the participation and the turnout here. Thank you for coming to NCAR, and hopefully have a great workshop and engagement around the expectations for Geoscience Data Commons. So I'm Thomas Hauser. I'm the director of the Computational Information Systems Lab, CISL. So CISL runs the supercomputer and the cyber infrastructure around data. We also do software engineering, kind of performance engineering. And modernizing our geoscience data infrastructure is a key priority for us over the next years, really integrating the data from all the labs into kind of one easy-to-use infrastructure. That's really the goal. So first, a few thank yous. Thank you to the organizing committee and Doug for pulling this all together. Can this organizing committee stand up? Who was, yeah, can you stand up? Who was on the organizing committee so people recognize you? Again, big thank you. Thank you to the CISL admin team to making sure the workshop is running smoothly. And then also thank you to our multimedia team, because we are live streaming this so people can participate remotely. That's all what I want to say. I think Doug is doing some more introduction. And please engage, provide feedback. And this is not the last engagement. I think while we develop our infrastructure, we need consistent feedback, input, what's working, what's not working, how do we improve to really stay leading edge in this space. Thank you.
All right, thanks, Thomas. Give this a try, and thanks to everybody for joining us and traveling out here. Really looking forward to the workshop and appreciate everybody coming to participate. And look forward to some very constructive discussions here over the next few days. So once again, I think Thomas covered this, but thanks to the organizing committee and steering committee members for putting this together and really providing a great foundation for the program we have over the next few days. I just wanted to briefly review our code of conduct that was available on the workshop website, but what we really want to emphasize is being open to new ideas and being kind to one another. But some of the foundations are considering new ideas, sharing the air, intentionally making room for a variety of voices during this event. Also, just a warning, when we do the question and answer session, there's ceiling mics, and they might even be on now. But if you look to the ceiling and you see a little green circle over some of those things, that means they're live. And if you have conversations on the side, those ceiling mics can pick you up really easily for those in the live stream. So at least be aware of that with whatever you're saying. Acknowledge teamwork. Let's appreciate working together and acknowledge one another. And then if you run into any issues or problems during this workshop at all, please reach out to either Tasha or I or any of the workshop organizing committee members. We want this to be a comfortable space to work together. So some of the goals for this event, just broad brushing, looking at this, through these plenary sessions and through the breakout sessions that we have in the workshop. We want to learn about existing capabilities and user needs as they are now in terms of really data science research and data curation, a vision for future capabilities, and then from a variety of perspectives, discuss the topics that will inform the workshop reports. There will be a report that results from this that describes community recommendations for geoscience research data commons needs. And then, we have some selfish reasons for that internally at this institution that Thomas just mentioned. It'll be used to, inform data services design at individual institutions. That's how we envision this. One is NCAR, could be used at others. And then to support a greater mesh of resources across institutions and organizations out there. So that's kind of the broad goal of this workshop. And then we want to build community. We want to meet people, make connections, see where we can move forward out of this workshop working together. So for the agenda overview, we've sent out lots of emails and links, so thanks for your patience with all of those. But for today, we'll have a plenary session, which is more or less starting now, and it'll go till 3:15. That'll be followed by a coffee break. And then we'll have breakout sessions, and there are room assignments for those breakout sessions, and those will go from 3:45 to 5. We'll come back here and wrap up, have a bit of time for discussion, and then the bus will depart. It's scheduled for 6 o'clock, but if everybody's on there, it might be able to leave a little bit earlier. Tomorrow, it's going to be a full day. We're looking at a couple of different themes: data commons, analytics research, and educational user needs. That'll be the morning session. All these sessions follow the same structure: plenary, coffee break, breakout sessions, then kind of a report out. And then there will be a lunch following that on your own in the Mesa Lab Cafe. And in the afternoon, it'll be data producer needs for curation and consulting services, following that same structure, and then we'll wrap up tomorrow around 5 o'clock or so in that hour. And then on Friday, we're leaving this open. So if there are any topics or areas that you'd like to cover as participants, that aren't pre-covered or assigned as we have it now, we'd like for you to add suggestions to a Slido instance, which is kind of the question and answer form for the live stream, throughout this workshop. And then you'll have the opportunity to upvote or downvote those topics throughout the workshop as well. So we'll have a breakout session that's kind of to be determined by the participants on Friday. And then we'll have wrap up and discussion on next steps after that in the main seminar room, and then the bus will depart at around 11:30. So that'll wrap things up on Friday. Nice to, yeah, okay. Thank you. And then, so here's the link to that Slido. So you can either, use your phone or on prior slides, there were links to these slides all over the place, and we can send that out as well. But there's links to all these different resources from this slide deck. But this is basically a forum where you can either ask a question. It's mainly set up for live stream users. But what we'd like you to do is add topics that could be potential breakout topics for that Friday morning session, and then upvote or downvote those topics throughout the workshop. And then we'll have a final opportunity to look at that on Friday morning at 9 o'clock when we convene at that time. So as I mentioned, these sessions will be live streamed for the presenters that are okay with that, and recorded. And then we have a number of different breakout rooms. It appeared that breakout room Chapman room might have some conflicts, so we're going to make sure that's open for us today. But otherwise, I sent out links to breakout room assignments. I'll put that up on the slide on the screen once the plenary concludes as well. And then there's designated moderators as well as note takers in each one of those rooms. Here's a map of where things are. So this probably works best if you get the connection to the slides, but we'll make sure you find where you need to go. Just ask questions. And then the first floor, if you haven't seen the cafeteria, there's some exhibits out there. Just kind of wind your way around. Let's see if I can get that to work. Yeah, there it goes. And that's the cafeteria. That's available for some grab and go things through much of the day as well. So here's some important links. There's the QR code for these slides. And once again, I'll send out a link to these slides. And much of this information is connected to from the agenda that's available on the workshop website. Does anybody have any questions on logistics? If not, I'll move forward to a couple of introductory slides, and then we'll proceed with the plenary session talks. So a little bit of background about what we have going on at this organization and what's motivated this discussion and kind of led to the idea of this workshop working with others is we have a number of different data repositories that are supported at NCAR at various labs. So the way NCAR is structured, we have about 8 different labs that focus on different science topics. And organically over time, they built repositories up to support their specific domain user communities. And they're really tailored towards the what we call the legacy download and analyze workflow model. So if you want to come into NCAR, you can actually go through a common search and discovery interface and find data sets that are stored in these various repositories. But once you land on one, the look and feel is unique to that repository. The data transfer and access capabilities are unique to that repository. And in some cases, the data formats are unique to that repository. So if you want to compare, analyze data sets from these multiple sources. First, you have to work through those different systems, download the data to your local platform, likely clean the data, and then you can run your analysis software. And that could be time-consuming and inefficient. So that's kind of what we're looking at. It's been a great system for a long time, but now, can we do things a little bit better? Then we also have high-performance computing systems, and those have direct access to selected data sets that are stored. They're available through some of these repositories, but they're limited to users with NCAR high-performance computing accounts. Only a selected subset is really available to access directly from these NCAR HPC systems. In some cases, users actually have to download data from these web UIs onto storage on the high-performance computing systems to do their work. And then finally, there's no good search capability outside of ask where a data set is located on storage right now. There's not necessarily a programmatic way to find where things are if you're on the HPC systems. So in general, we're not realizing the full research potential of our wealth of data assets. So we're just looking to see how we can do a little bit better. So what we're looking at internally here and trying to get feedback through this workshop and other mechanisms is, migrating from an architecture of existing loosely connected data systems that don't really, support a holistic analysis environment to something that's more of an integrated research data commons. Through this, we want to have repository services, that support the FAIR principles and have trusted repository services. So we don't necessarily have to have 5 different trusted repository services with 5 different cyber infrastructure stacks. We want integrated tools for data analysis and exploration. We want to support AI and ML workflows, which is a big thing. And then, one large component is broadening participation in data science research and make this easy to use. And these are concepts that we want to move forward, through this workshop and other means. How can we bring more people into data science? If they don't know how to use a command line or use, submit batch jobs or do all these different things, how can we make it easy for people? And then finally, this positions us to integrate with broader national scale cyber infrastructure initiatives, such as what's called the National Discovery Cloud for Climate. And this slide is just an illustration of what, integrating with the national scale cyber infrastructure, even global scale cyber infrastructure looks like. Possibly a data layer that looks like a kind of a large agnostic object store system that isn't necessarily tied to one compute service, but it's accessible from a variety of compute services. And our current architecture makes it really challenging to participate in these kinds of initiatives when you have these 5 separate repositories. And then Matt will say a couple words, and then we'll move forward with the plenary.
All right, thanks, Doug. So I'm Matt Mayernik from the NCAR library, and I just wanted to put this up at the beginning to kind of answer in a big picture, what is a data commons? And as Doug's talked about, at NCAR we're moving in that direction. Many others in different communities are moving in that direction. But this might be a term you're not familiar with. It's a term I hadn't really heard or encountered much even a year or 2 ago. So I wanted to pull this up, which is the Global Open Research Commons. This came from an international working group from a number of countries, and the background and details on this are described in the report, which I don't have time to go through. But they looked at over 20 research commons across the world, from large-scale data systems to national-level cyber infrastructure data commons projects, and kind of combined, what did all these have in common? I came up with this framework. And really what I want to emphasize here is I think all of the aspects that you see in this chart are on the table for discussion here. Obviously, we'll spend a lot of time talking about the stuff listed on the bottom, the compute, the services. We want to get some good insight into that, as Doug mentioned. But that stuff has to have the other components in order for it to work at a community level, for it to be usable, for it to be equitable, and all those kinds of things, for it to be interconnected through standards and engagement and so on. So take a look at this if you're interested, but I just want to emphasize that we're really interested in your perspectives on all aspects of what's shown here throughout the course of the workshop.
With that, we'll move on to the plenary. We have Dr. A here from Howard University. She said, please call me Dr. A, and I appreciate that. But anyway, Dr. A is an associate professor of Africana Studies and Data Science at Howard University. She holds multiple degrees in African American Studies, Sociology, and Data Analytics. She serves presently as Director of Graduate Studies for the Master's Program in Applied Data Science and Analytics, advancing Howard University's first major effort in becoming a hub for data science, social justice research. So thank you very much.
Thank you. Hello? Can you hear me? Kind of, sort of. Oh, this is much better, but okay, I guess I'll hold it. Good afternoon. I want to have a timer, but there's no timer right there.
There it is, yeah, and I'll let you know.
Put it here. Hello, hello. Good. Okay. Thank you. Welcome, everyone. Welcome, online viewers. I think you're here. I think you're here. Thank you for joining me, and it's an honor to be the first speaker in this plenary. And thinking about data commons, I want to kind of somewhat recycle a presentation I've done for a couple of state orgs for you all, and thinking about how we can connect, particularly with the human capacity question, right? And access and community being a part of the community and common being a part of the conversation we're building. So in 2002, does anyone remember Verizon's big "Can you hear me now" ad? Everyone, can you hear me now? Someone's like, "Can you hear me now? Can you hear me now?" And then it breaks, right? So that was big. The Verizon guy's still there, I believe. I think now he was T-Mobile, right? But the idea of having access, being accessible, being in the zone of connectivity was important, right? And today that conversation also, I believe, resonates today. How are we thinking about data and it being accessible to people who need it? One, those who have the skills to be able to process it, two, and it having this, I would say, common good, right? So we're familiar with that. So let's move to 2023. We have a picture of Beyonce Super Bowl. She also has her own version of the Verizon ad, and she's trying to break the internet, right? So at one point, we're trying to connect, then at some point, people are just trying to break it, right? Two different conversations in the same data verse. And then in 2021, in the middle, we see, anyone see the guy in the cowboy hat?
Yeah.
Who's that?
Is that Bezos?
Bezos, right? So he's trying to like leave space, like just kind of go somewhere else that we haven't been to yet, right? So when it comes to data, technology, not everyone's on the same page. Let's be clear. Not everyone has the same investment. Not everyone has the same point of view about how we should have access, who should have access, what is it used for, and if we should just stop what we're doing and do something totally different, right? But I think in this group, in this conversation, we're trying to come to some common ground, right? Because we're knowledgeable of the fact that there are many people who are not even at the level of what we're thinking about when it comes to data and access. And many people are just, no one's seeing them. No one's hearing them. They're not in the data. And they're facing some of the biggest pressing issues. We believe the data that we have access to can solve their problems, right? So I fast forward to this image. This is from 2 years ago, the Bronx fire. I'm from the Bronx, New York. I'm trained as an African American Studies professor, but I began to get involved with earth science and geoscience work, particularly around COVID, right? I had realized that AI was deciding everyone's decision: where do you go, what do you eat, what do you watch, where do you sleep, and if you had access to a vaccine, right, or not. But also in the Bronx, there was the Bronx fire. And I apologize for the vulgarity in the statement that was posted on the internet, but a fire had happened in an apartment that had many violations according to data, right? Violations everywhere, and a fire broke out. It killed numerous people, and this is happening a couple of times in many spaces. But the author of the post was furious because we have enough technology to go to space. We have enough technology to figure out where a wildfire may be happening. We have enough technology to figure out satellites, local devices. There's so much technology everywhere, but we cannot figure out how to stop common house fires. They're taking people's lives, right? And the anger that the metaverse exists, people are going to space, but we can't give access to those who possibly need it in stopping situations that, by this time, when it comes to poverty, when it comes to healthcare, there's so many issues that we have so much information, we should know better and do better, but the connection isn't there. So the work that I've been working on is talking about data pollution, where for some areas of the world, data is everywhere and people have access to it. People have careers and businesses with it. But there are other areas where there is no data. And how do we kind of create this bridge where areas where there isn't any data, there is data, but people don't know what the data says, and how do we create a loop where we can allow people to not correct, not clean, but create their own sense of quality data for themselves in their own language. So I look at 3 case studies we've been working on: Mossville, Louisiana, Manchester, Houston, Texas, and Miami, Florida. The work that has been happening in my lab, I apologize for the blurry picture. I work with my students in the Core Futures Lab at Howard University. CORE stands for Community-Centered Openness, Research, and Equity. And I have 3 grad students, 6 undergrad, and 6 high school students. We came here last year to the lab. There's a picture we see right here. And we were just excited to kind of just be in this space and see how much NCAR has, right? But the biggest problem we have with NCAR data, we talked about a few seconds ago, I cannot access NCAR data without NCAR person, all right? So I can be in this space, but not know how to like take the data, look at it, analyze it myself without someone who's from NCAR, who's trained on NCAR's common data knowledge to be able to access for myself, right? So then NCAR's staff, right here, came to Howard to also help us do that. So we have this interchange between ourselves, our students, and the NCAR scholars who are helping us kind of figure out how to better improve this loop for our communities. So I'm gonna jump around because I'm talking a lot. So first case study, so we look at, I think there was a storm in Texas again 2 days ago, right? So Texas storms, unfortunately, there was a social media post where a researcher plotted the NextRad satellites, right, over Texas, overlaying it over Black communities. So we can see in this image, there are definitely dead zones. So we see areas where we see large populations of African American communities not covered by these radars, right? So the question is, are they getting the same information that other communities are getting when it comes to warnings? I would argue they probably aren't. Louisiana, Cancer Alley. Cancer Alley, known for, unfortunately, its toxic situations. The question becomes, how does Cancer Alley exist when we have an EPA, right? How do more companies continue to move into Cancer Alley when we have the EPA and state regulation that says that there are certain levels of toxicity that should not be in the air? Right? How is that happening? So we look at another situation recently, 2020, where another company was moved into Cancer Alley, and they were moved in based upon EPA data, right? So the EPA, based upon EPA's data, this company was given access to move in to Cancer Alley. So when you go to the EPA Air Now website, they'll tell you, Mossville was the community we're looking at, they'll tell you that the air quality in Mossville is good. Right, so we have, go back, Cancer Alley. EPA says air quality is good. All right, we see a somewhat of a gap, and if I've traveled to Mossville, get some pictures later. You can walk in Mossville and it just smells bad, right? Like you can smell the toxic in the air. So the question is, how is the data saying one thing, but people are living an unfortunate lived experience when it comes to their health and exposure, right? So how do we clarify these data gaps, where what people are living and what people are, what is being told about their communities publicly is not accurate. So we've been working and looking at some mapping. So mapping out where's Mossville, what is in Mossville. So according to the GIS maps, we know that there are many petrochemical companies around the community that are alive and active, so we can see what we smell. If you go to the Air Now Toxic Screen website, they'll tell you how much toxic chemicals are going in the air, all right? Then if you look at an aerial view of this place, can someone tell me what is this brown? Is this, so it's here is blue, but real life is brown. That is the, is what? The river. The river, there's the water, right? So according to the state, they will say, so people in there, what's coming out of their faucet is looking like this, right? But according to state documents, they'll say, oh, the water's good, right? So the question is, like, there's data on this side, then there's people's lived experience as far as their data, right? So how do we create loops where people can give their own data to an existing data set that clearly is off, right? But many times these government data sets are the ones that are kind of going forward where in most cases, the communities like these are not included in a data set, right? So how can I, as a resident, give my own data to a data set that doesn't look that doesn't consider me and my experiences? So we look at GIS data in the 10 years in Mossville, how much the petrochemical company has grown in that community. You can see spatially, they've kind of taken over the high school, the park, and many residential homes in that area. So this is from one of the residents who lives across the street from the chemical company, and you can see they're burning right here. And that's what you smell, like the chemical company burning. But again, EPA will say the air quality is good. So I'll fast forward to the next one. So if you drive through Mossville, you'll see abandoned lots because the company paid community members to like leave and destroy their homes on their way out. So there's this flat lands. That creates a whole other issue when we get to the EPA. Did I miss on the slide? Oh no, I'm missing a slide. Justice 40 track. I'm missing a slide, I'm sorry. So if you go to the Justice 40 track and you bring up Mossville, Mossville is not considered a disadvantaged community. Why? Because nobody's there, right? So, I'm sorry. There's been a large reduction in those who live in the community, right? But those who are there aren't able to get access to grants because they're not considered disadvantaged, right? And a lot of that has come because of the chemical company pushing them out. So even data products like Justice 40 that's supposed to be creating equity and justice for communities, that data set is also very off, right? And there isn't a feed-in loop for people to kind of update or give quality data to that data set itself. The next example is Manchester, Texas. We see another community that is surrounded by landfills, trains, waste management facilities. They do not have an air quality monitor in their community. The one that is in their community, it's outside their community, and even that monitor says green. But if you live in that community, you go in there and you smell it, you can tell it's not quality air. My last example, I don't know why these slides are blurry, is Little Haiti, talking about air quality again. They also have an issue with transportation and quality data around transportation data and highways and heat and creating urban heat islands. So ability to kind of be able to track how hot it is in certain communities depends upon where monitors are located. And many monitors in urban communities are near the airport, right? So Little Haiti is a community that's surrounded by highways, not too many greenery, and it's extra hot compared to other areas of Little Haiti. And we put a monitor there and we're able to collect some data. So what we've been trying to do is allow our communities to kind of have their own monitors that are 100% solar, runs on Wi-Fi, and they're able to have access to their own data. The second level of this conversation is how can they see what is being said about them at the federal level. So if I look at my community, what does NASA, what does NOAA, what does EPA say about me? And then what am I seeing? Can I compare that and begin to maybe give some feedback to these agencies that what you're reporting isn't accurate. I'm getting something else. And then can they use that data to either fight some legal battles, have some health support, and also get some grants to be able to kind of change their community situation. So my students are helping build this air quality monitor, which we're calling Breathable Future, which looks like a house, more friendlier than a kind of a satellite device or something that doesn't look like your community. We're hoping community members can use that to collect their own data and be empowered. And I think that's the last slide. Yes. Thank you.
And we'll have some time at the end for discussion, but I think Dr. A has to head out of here and teach a class. Is that right? All right. She'll be around, though. Okay, so up next we have Tasha Snow, Dr. Tasha Snow. She's a research scientist with the NASA Goddard Space Flight Center in the University of Maryland, working to better understand Greenland and Antarctic ocean and glacier change and how it will impact the planet. She specializes in remote sensing, open science, and cloud computing, and she's the co-founder of CryoCloud JupyterHub that aims to help usher cryosphere research communities into the virtual cloud and build community practices for modern science workflows. So thanks, Tasha.
Hello, everyone. Let's see if I can get this on. You can hear me? All right, how's that? Good. All right, Thank you for the introduction. Thank you so much to the organizers of this awesome workshop. I'm really excited to interact with all of you for the rest of the week today. My name is Tasha Snow, as Doug just said, and I'm going to talk to you a bit about CryoCloud, which is the JupyterHub, a cloud computing platform for our community of cryosphere researchers to be able to access the cloud. And what we've learned as we've been using CryoCloud is, to think of open science as a process and not a product. So that's what I'll be talking to you about today. And just to acknowledge my collaborators here first and our funding agencies. A lot of people have put a lot of work into this, some funded and some not. So to kind of get us started, I'm going to leave you with my takeaway to start out here. And that is that social innovation and data really need to be at the forefront of our conversations. This is where we kind of see huge gaps in the open science and computing that we have been doing in CryoCloud. In terms of social innovation, what that means is, the policies that we have that we use to produce data and do science. How do we collaborate? How do we string tool chains together? How do we communicate? All of these things are part of the social innovation. But what research has shown is that in terms of innovation success, most of the success is really around the social innovations and not around the technological innovations. So, for example, coming from NASA, we have policies that were built 20 years ago by people who lived in a very different technological era, and a lot of different legal policies that are from back then, and now those serve as roadblocks for us to be able to do open science in NASA. And so rethinking, reimagining what this sort of social innovation, social spaces might look like. Also, that visionary data practices are required. So scientists in general don't tend to be data producer experts. A lot of us have had very little training, but we are the main people making the decisions about data production and don't have a lot of guidance about best practices. I'm not as familiar with NCAR, but definitely in a lot of the spaces that I've worked, this is the case. So thinking about what those are, and data is obviously very important for many of you, but thinking about Maslow's hierarchy of needs in science, the data sits at the very foundation, right? So if we don't get data right, we can't do science, we can't access the data, everything kind of falls apart. So it's really important to spend a lot of time in this really non-glamorous part of science. And so as we think about how to kind of rectify some of these issues and a lot of the problems that you guys are going to present about later today and the rest of this week, a lot of these problems have been solved outside of academia in our spaces that are represented here. And so making sure that we have active engagement by broad scientific and open science communities at all levels is going to be really important for us to not just catch up to the cutting edge, but also to become the cutting edge of science and open science. So with the rest of my talk, I'm going to discuss more about open science, community building, and infrastructure for whatever community it is you're a part of. So this should really be transferable to whatever community that is. I'll talk about open science in the cloud, models for serving the community, and our lessons learned. And so kind of to start, in terms of open science, many of you are familiar with that. The cloud is a space where we can build more collaborative, reproducible open science. And for anyone not familiar with the cloud is a virtual space where you can put data, servers, all of your software tools that are curated to your needs all in one space. It does not include the internet or a router. And by putting these into one place, you don't have to necessarily download the data. The transfer, there's less overhead in terms of accessing the data, so it can be a lot faster. And what Shel Genteman shows here in this paper and others is that the cloud can become not only a tool for changing the realm of possible questions, because we don't have to download data and things like that anymore, but it also can be a space where we can advance science and inclusivity simultaneously, but we have to be able to use it right and create the right data practices to do that. And the way that, an example of how we actually brought in inclusivity in science at the same time is kind of shown here in these tweets. You can process massive amounts of data from any sort of computer, in this case a $36 Raspberry Pi, and you can do it anywhere as long as you have a little bit of internet, so from your cell phone or on a flight. And that really changes who can access data and science, and by getting it into spaces that haven't historically been able to use it, we can have greater impact. So as we have this new cloud space, we need new organizational models to use it. And this is where CryoCloud comes in. So CryoCloud came out of the ISAT-2 science team. ISAT-2 is a NASA satellite that is a laser altimeter, measures the surface elevation of the Earth. And the science team met in May 2022 and talked about the fact that the cloud is a space that has non-intuitive pricing structures, computing options, and infrastructure. The pricing, there's poor documentation, it's costly to use, so people were ringing up a lot of money without meaning to, without getting anything done, and it wasn't obviously more collaborative or faster. And myself and Joanna Milstein, who is my co-founder for CryoCloud, were sitting in the audience, and this really didn't ring true to our experience. And that's because the cloud platforms that we've used before have been built by 2I2C, the International Interactive Computing Collaboration. This is a non-profit service provider for flexible and interactive computing infrastructure. They have a mission of science and education to make cloud computing as seamless and functional as possible for science, and also as cost-effective. And a lot of the developers in this team are some of the lead developers for the Jupyter ecosystem and other open source tools. So the leading experts in cloud in the world, and everything that they build is contributed back to open source communities. So what we decided to do was to partner with 2I2C to build a cloud computing platform with bumpers. So the idea was that CryoCloud would be a simple and cost-effective managed cloud environment for training and transitioning new users to the cloud, and also determining best practices. Who should be using the cloud, who should not be using it, how do we use it in this new technological era? A lot of our practices really need to change in using the cloud, and we really don't know what communities should be, these kinds of things yet. So we built crownthecloud.com. This has our Jupyter book, which has all of our training material and content, and our Jupyter Hub as well. And some of the things that we've accomplished since starting in October 2022 is that now we have about 380 users. We've supported 12 software and education workshops. Joanna is, at the time, a graduate student, led a white paper to NASA, and Wilson Satoff was a graduate student also. When he got an EOS article submitted, it's actually submitted and accepted, not yet published. We have an AGU Open Science Recognition Prize. We've published our Jupyter book, all content and presentations, in our Zenodo community, and we have 2 community surveys. And through those community surveys and interacting with our users, we've found the advantages to a community platform like we have, especially finding that CryoCloud can kind of serve as a glue for our communities. And so from our surveys and the feedback that we have so far, we've found that users have an overwhelming positive experience with the cloud. So cloud computing, they think that cloud computing makes collaboration easier, that it's the future of science, and that they would recommend CryoCloud to a colleague. On top of that, we found that the reason they are wanting to transition to the cloud, unsurprisingly, is around data. So not needing to download data or store data as data volumes grow exponentially at this point. What was really exciting and interesting to see is that 79% of our users are early careers. And actually the leads for CryoCloud are also all early careers. But what this means is that not only are our users going to be early careers, but the people who are experts in the cloud and open science, the people who are really like the heavy lifters in terms of using the cloud, are going to be in this space. So having them as part of the conversation and learning what is going to be the next stage is going to be really important. And I'm excited to see a number of early careers in this workshop to begin that process. Another thing that we learned is that having different kinds of users in one space really accelerates feedback and collaboration. So our users can use a number of different kinds of data sets, a number of open source tools. Some of them are community-centric, and some of them are, say, NASA-centric or larger. And what's exciting is that when a lot of these developers are actually in the CryoCloud space, also developing. And so when a user has an issue with their tool, they ask a question on our Slack, the developers can actually respond and see that immediately. They can go to those bugs, replicate them in the same environment that the users are working in and rapidly fix that bug. Not only that, but they can also see the questions that people are asking about the tooling and can start to see the gaps in their tooling as well. And then what's also pretty cool is that by having multiple kinds of developers that are in different parts of our community, these developers can start to align their development because they're interacting. So they can start to create more integrative tooling that reduces redundancy and reinventing the wheel and starts to work better together. So what we end up building is this open source community without boundaries. And it's really working to empower our communities to do what they do best. So scientists should not need to be the leading cloud engineer, or like be learning cloud engineering. And they also won't do as good of a job as 2I2C can, who are specialists. So they should not be needing to learn how to do the cloud. Our tool developers can be the experts in doing their tool development, and having all of them interacting will create a more synergistic space. And by combining all of these groups together in one space, we're creating a shared community resource model. So we're not having to have multiple Slacks, multiple JupyterHubs. All of that sort of cost sharing ends up happening. There's expertise sharing. And it really makes it so that we can build in one direction really easily instead of having this closed science sort of siloed, reinventing the wheel sort of system that we've kind of had in the past. So with this very nice, successful community platform, we've also found that barriers still exist. And I'm not going to go through all of those barriers at the moment, but I'll talk about the main one that you guys can probably all guess. As I mentioned, the main motivation for switching to the cloud is data. Also, the main barrier to using the cloud is data access and storage. So as Doug mentioned, there's a lot of issues with the data. And I don't need to go back through those, but data formats are not compatible with modern tooling. Every data set can be accessed differently. You might have different passwords. You might have to download the data, so you can't even use the cloud to its full potential. And that's a really big problem, as downloading data and storing data is really expensive in the cloud. And so I would argue that this data problem, understanding data formats, how best to create and produce our data, is the most controllable problem we have. There's a lot of innovation that we can do here, and it's the most impactful solution towards creating analysis-ready data. And this is going to be really important, right? As I mentioned, scientists are not the experts in creating this data, and so having expert data producers in this conversation is going to be really important, and having them interacting with scientists more could help to solve this problem. But as I mentioned before, this is also not a glamorous thing. Like many people, it's really hard to receive funding to think about what chunk size you should create for your data, right? But that's one of the most important things that you should do in terms of creating your data set. So with that, I'm going to close. Social innovation and data are the most important parts of, or some of the big gaps that we have in open science. And CryoCloud is really thinking a lot about the social innovation side and wanting to support the data practices side, but we have a lot less expertise there. But as we do this, again, a lot of communities outside of academia have solved some of these problems, and so active engagement with them at all levels will be really important. So with that, thank you.
All right, thanks, Tasha. As I mentioned, we'll have time for discussion and questions at the end. So next up, we have Angel Alos. As a member of the Forecast and Services Department at ECMWF, Dr. Angel Lopez Alos is currently leading the Common Data Stores team, whose main task is the implementation and operational management of the Copernicus Climate and Atmospheric Data Stores. Before joining ECMWF, he was part of the data specifications teams for the EU Inspire Directive at ECJRC. So we're excited to have you here and look forward to your talk. Thank you.
Yeah. Thank you, Doug. Can you hear me? Okay, great. So glad to be here representing what we are doing in Europe and telling about our story and what we are planning to do next in the future. So I'm talking here on behalf of a lot of people, so no space in this slide to mention all the people that is behind what we are doing. So different teams at ECMWF, but also outside, other partners that we collaborate with. So it's plenty of people. So thanks to all of them. I'm just representing all these people. So just to put in context, for those that are not familiar with the data store, with what we call the data store. So we are ECMWF, the European Center for Medium Range Weather Forecast. And we were entrusted by the European Commission to implement 2 of the Copernicus services. Copernicus is the Earth Observation Program of the European Union. So we were entrusted to implement the climate change and the Earth monitoring, but we also collaborate with the emergency management, but also with the Wikio platform. So in order to support the implementation of these services years ago, in the 2018 around, we put together what we call the climate data store. The data store is a kind of infrastructure that was aimed to support the implementation of the service. At that time, we decided to do an in-house cloud to support the system. We start using the technologies that at that time we considered they were the more suitable in order to support all this, and we start integrating different data sets. So as everything in life, after years of operation, we have realized that we need to improve the system. There are some technical barriers that we need to change in order to continue growing. Because the reality is that we put something on top of users that they really appreciated. It was really successful, much more successful probably than we were expecting at the beginning. So we are now a huge amount of users really demanding a lot of data from us, and we need to be able to cope with this demand. And at times it's not easy, so we need to evolve. We need to maintain all the things that we were doing because our formula really demonstrate being really successful and well appreciated by the users, but improving. So how to keep this balance is not easy. So I'm not talking about the old system because we are about to open the new one. It's about to be open in weeks. The important thing is that we are going to maintain the same elements that we consider were the baseline of the successful implementation of the service. So what we tried to solve at that time, there is different data sources that they were distributed. They were, people need to go to different places to find different data, different ways of accessing the data. So we put in the middle the data store infrastructure. So this was bringing different layers from the simple front end, simple interfaces for users, just the API, user interface, just to discover and being able to, in a single place, to discover different data sources, to do subsetting, and to retrieve data all in the same formats, all in the same navigation of the or user journey. So an important element that we put together is the adapters. The adapters is a kind of component that allow us to interface with different data sources. On top of that, we have what is the core of the system, and this is a way to support the implementation of the catalog by using different standard metadata. And so we have the broker, we have the quality of service rules, which allow us to manage the traffic, the incoming requests, and to dispatch this to the different data sources. We also have a stronger function, which is the evaluation and quality control, in order for users to trust the data that we offer. And on top of this, we have the interfaces that we expose to the users. We have the user interface, that we have a way for users to do click, and then subset the data and retrieve directly from there. But we also have the API, which is quite simple to use and is allow users to do things. We had a component which was the toolbox editor. At that time was revolutionary, I will say. It was a very a very good idea, but it demonstrated that it was a very constrained environment. So we have decided to move this completely out. We have decided to move to more open source concept, and now all these tools are what we call now the Earth Kit, and it's a set of tools that people can deploy and run everywhere. Also, on top of this, what we have put is a lot of training material, Jupyter notebooks for people to know how to interact with the data, how to access the data, and so on. Important thing is that a lot of our components are also used for other platforms in order to create better synergies. We have Wikio, for example, and some of our components are able to work in Wikio in a way to better communicate and access better the resources that we have. So the whole idea was to go for this huge amount of data, these huge data sources, to make something that is meaningful for users and easy to access and easy to use. But there is always problems. So one thing is what you can say on a presentation, but at the end, the reality is not so nice. I mean, the data sources are always growing. There are always more and more data and more detail, and the level of granularity is always higher, and the scale and everything is much, much bigger. We have now, for example, at ECMWF Era 6 coming, which is going to be huge, I mean, compared with what we have now. So all these data sources are growing. You have your infrastructure in the service, which at the end needs to continue providing the service. But the problem is that in the other side, it's also growing. It's more users, highly demanding, so there are more technologies now, and they require more data and more immediate data, more volumes. Not all the users are as friendly as we were expecting. Not these nice researchers doing things, or you have bots there that are really pushing, and whatever you open, they take it. You have threads, you have malicious users that they, instead of registering one account, they register 20 accounts in order to cheat your system. So this is something that is creating a real bottleneck in your infrastructure. So what it was a magnificent system, after 6 years, you realize that something needs to be done, because otherwise you are a bottleneck between one side and the other side. So what to do? And this is what we are aiming to do. This is just to demonstrate that it's real. I mean, I'm not talking here about something is, oh, probably it will be coming if we do. No, it's a reality. I mean, the first image demonstrate the request that we have in the queue, so incoming request to the system. The green line demonstrates that the system is continuously running, so it's at the highest speed, so there is no balance in the line, it's always there. And in the second one, you see the green line is what is running, and the blue line is the users that are really waiting. So our aim is to have the green and the blue lines the closer as possible, because this means that all the users that are coming to our service, they are able to have something running. They are able to really access the data at that time. And this is a real example of 24 hours. So it's close to 3,000 users, 1 million requests, and more than 150, and we are reaching peaks of 200 terabytes per day. So what to do? Because you need to do your infrastructure to grow at the scale of the user side and the data sources side. So you need your resources to scale, and for this, we had this in-house cloud, and we are moving now to another cloud, which is more integrated at ECMWF level, which will provide us with more resources in order to scale up much more. We have this plugin, a modular architecture, so it means that we create components that we can reuse and that we can scale, and then we can create more elements of these different components. We are pushing hard for the FAIR principle, so we want all our resources to be findable, accessible, interoperable, and reusable, and this means a lot of things, and so we are trying to go in this direction. Again, the simplicity and the consistency is key. So I think we need to really be able to do simple things. The more complicated you do the things, more errors, more difficult for people to understand what you are doing, and needs to be consistent. If you start changing things and the user is using something, but suddenly you change it because you consider it and they start having problems and then you interrupt something that they are doing, so it needs to be consistent. Automatization is something also very important. Doing things manually slow down quite a lot the things that you do. So if you manage to automatize how you integrate things, how you test things, how you scale up things. So all this automatization for us is key in order to be able to be dynamic and to be able to serve all the things that we do. The configurability, more or less, is aligned with the automatization. So we are able to reconfigure the system. For example, I was talking before about the QS. The QS for us is at the core of the system. So if you have 3,000 requests at the same time, and you only have certain amount of resources, you need to decide who go first, why, and who needs to wait, why need to wait, and be able to manage all this without receiving too many complaints, because there is always users complaining. When you start putting this kind of rule, you have to wait, you go first, you go second. So how to manage this is also very important. Also the synergies with other platforms. So when at the beginning, when we started, the CDS was working on its own. It was a kind of a experimental platform, but now there are plenty of platforms. We have Wikio, but there are other platforms. We have the digital twins that we are also involved on, and there are things happening at ECMWF, but also in other organizations as ANCAR or any other. So we need to be able to really find synergies with all these organizations in order to exchange data, but also components, services, whatever we can do in order to facilitate, to create all this environment that is good for users. So this point me to the next. We need to be open to collaborate. I mean, we cannot work in our own. I mean, people needs to be, what the data we are managing at the end is global. I mean, so we cannot live in our island. We need to be open to share and to connect. So at the end, we need to be able to evolve all the tools and all the functionalities that we have in a way that, coming back to my previous slide, sorry, we are able to be in balance with our ecosystem and in being able to grow with the environment. I think this is something of the things that we are going to discuss in these 3 days. So yeah, just to say that we have the old system. The beta of the new system is coming. We are now testing, as I'm telling you. One thing is the thing that you can sell in a presentation, say, oh, it's going to be a fantastic system, bring in here, that. But the reality is not so nice. So when you start testing, you need really to benchmark with the things that you are doing now. You really need to guarantee that what you are going to open is going to really be successful. So we are in this phase. As soon as it's open, we will let you know, because we will be glad of having you on board. But you can follow the last status in this link. So with this, I think I conclude my.
All right, thanks, Rahul. And then we're also actually migrating or putting a copy of ERA5 on AWS right now. So that's just one thing that's going on that'll help you. But okay, so next up we have Deepak Cherian. Deepak is a PhD, is a forward engineer at Earthmover PBC, working to build a data lake platform for multidimensional array data in the cloud. Over the past decade, he has actively worked in the open source scientific Python community to advance the limits of what's possible with Xarray, Dask, Zar suite of software, colloquially known as the Pangeo stack. So we're happy to have you here.
Thanks, Doug. Can you hear me? Right. So I'm here to talk about what data commons might learn from the Open Science Software Commons. thanks to the organizers for inviting me to do this. It gave me the opportunity to engage with some ideas I wanted to engage with for a while, but just didn't have time to. And I apologize for the missing font. My name is Deepak Cherian. As Doug mentioned, today I'm a forward engineer at Earthmover. Earthmover was started by Ryan Abernathy and Joe Heyman. And our goal is to rethink how people interact with n-dimensional array data in the cloud. So that's the kind of data set we are all very experienced with. And we're a team of people with research backgrounds and private sector infrastructure building backgrounds. For the past decade, I've been a physical oceanographer at a number of oceanography and climate research institutions, including this building. And during that time, it became very clear to me that the ability to work with data in all sizes and your ability to be expressive with the data sets you're working with was just a real rate limiter for how much research gets done and what questions you ask. And so I decided I had to do something about that because I had opinions on what I wanted to do with data sets. And so for about 7 years now, I've been very, very active in the open source community, primarily as a maintainer for Xarray. And then kind of grown out into contributing to DAS or a whole bunch of other things, generally as part of the Pangeo community and trying to push what's possible with that set of software. And so everything that I communicate today is kind of coming from that experience, and I've tried to ask myself, why does the open source software community work so well, and what does that tell us when it comes to data? And so when I got the invitation email from Doug, I was really excited. It's like the data commons, and then I realized I don't know what that means. So I asked for some help. And so he pointed me to this paper, which is pretty good. I agree with a lot of it, but I have some improvements to suggest. So it defines the data commons as a cloud-based data platform. There's a governance structure, an unnamed community who is somehow working with data. There's technical stuff, as Matt pointed out. There's the top half of the diagram, the bottom half of the diagram, and the bottom half of the diagram is about co-locating data and compute and software and stuff. None of this really spoke to me. I was like, something's really missing here, right? And I think it's the top half of the diagram. And it's kind of in the paper, but isn't fully centered. And if you start looking into commons, eventually you'll discover Elinor Ostrom, who's one of the all-time great humans, I think. She wrote this very influential book, Governing the Commons, the first woman to win the Nobel Prize in economics. And I love this photo of her. She's just sitting on a field, holding sunglasses, wearing bandana, casually writing things that will win her a Nobel Prize 40 years later, right? Isn't that a great model for science? And if you ask Elinor Ostrom, I watched a bunch of YouTube videos, and people ask her, what is the commons? And she says, it is a very broad term for a variety of shared resources, and there are more technical definitions here. One is a public good, which is a commodity or service that every member can use without reducing its availability to all others, right? So just keep that in mind. It's a thing that cannot be depleted, and I think data fits there, but some might disagree. And there is an idea of a common pool resource, which is kind of like a public good, but it can be depleted. The common example is fisheries. They can be depleted, right, and not come back. And Elinor Ostrom spent a lot of time trying to understand how to manage common pool resources. And so let's see if this works. Should be in. Ooh, there it is.
When Garrett Hardin published his paper in Science in 1968 on the tragedy of the commons, I thought, gee, he has just made this up. Because he talked about, imagine a pasture open to anyone. It wasn't, here's my data. It is imagine a pasture open. And in that imagined pasture, people didn't talk. They just put as many animals on as they possibly could because whatever was left to eat, somebody else would grab. So they weren't interested. Well, that became almost like a religion. And the presumption was that humans were helpless.
So I'm going to stop that there. Right? So it ends on humans are helpless.
But let's look at the
the second one.
IGBP report
She's talking about the
in
climate system.
88, where we're looking at a climate system, the climate system. Where are the humans?
She's asking, where are the humans?
Well, not there. They're not there. They're not there. They're not there. Oh, there they are. Oh, they're polluting.
All right, so if you can hear that, she went through the whole architecture diagram and said, not there, not there, not there. There they are, polluting. Right? And that video is very influential. Now I can't look at an architecture diagram the same way, right? Because, like where are the people? Not there, not there, not there, not there. There they are, analyzing. Right? But really, there's people everywhere. And I think this is the point Tasha was trying to make, right? Like, there's people developing Jupyter, X-ray, all of this. There's people running cloud compute nodes, all of that. And you can't separate the people from the kind of end user application that we usually think about. And we've tried to do some of this in the kind of Pangeo community. There's a discourse forum where we try to get people together. People show up on the X-ray issue tracker. But it kind of really just hasn't taken off. And I think part of the problem is because they're not co-located, right? The software is in one place, and people talk about software in one place. The data is somewhere else. And then there's this discourse forum where, I don't know, we talk about everything. It's just doesn't work, right? And so people have spent a lot of time trying to think about the open source scientific commons. It's clearly like a successful model, but no one really understands. I don't think anyone really gets why it's successful, and it's very, very hard. But Nadia Eghbal wrote this very nice book. And the first time I read it, it didn't really speak to me. The second time I read it, in preparation for this meeting, it just clicked, right? And so she presents an alternate theory, again, drawing on Elinor Ostrom, and again, emphasized people, which is what Elinor Ostrom was talking about. She was like, why are you thinking that people are helpless, right? And then she looks at the climate system, like, where are the people? And so Nadia puts forward the same idea. She says, open source software is not a common pool resource. It cannot be depleted. Instead, she tries to think of it as an externality or a byproduct of a maintainer community, right? And a maintainer attention is what she uses, which I think of it as just the maintainer community. That is the common pool resource. It can be depleted. You can make increasingly large demands on a maintainer, and they will rage quit and walk away, right? And then the community is worse off. And so people, again, I think is what we should be thinking about when we think of the commons. And GitHub, which is the platform that enables this open source software commons, is evolving to preserve that maintainer attention and manage it. And she makes this argument at the end of the book, fits with my experience. I'm going to move on, but just note that it's always about people. And so what can a data commons learn from the scientific software commons? I'm going to say data is not a common pool resource. It may be a public good. Software is not a common pool resource. I think it's mostly a byproduct. The compute infrastructure may or may not be a common pool resource, depending how you do it. But I think that's the most important piece, right? So this is, again, the top half of the diagram. I think we should be thinking about community, think of it as a common pool resource, and think of it as something that needs to be shepherded and organized and treated very, very well. And so this session is called Big Idea and Solutions. I think the idea from Elinor Ostrom's work is to focus on the people. Don't ignore everything else, but just center the people. And I think the solution is to build a space for people to help themselves and each other, which is what GitHub has basically ended up being for the open source software commons. And so I propose some rewrites. The paper says co-locate data, compute, software. I say co-locate people, data, compute, and software. Presents the data commons as a partnership between the data scientists and the disciplinary scientists. I disagree. I think it's all kinds of people collaborating around data. I myself have hit many of these identities depending on some various phase of research project I've been in. And I don't think it's a very helpful division. Instead, I think we should imagine a commons where people can collaborate around the data in ways that make sense for them at that point in time, and then let them evolve. Successful commons curate and harmonize the data. I think successful commons empower people to curate and harmonize their data, and then share that knowledge. I think this bit is really important. Doug asked me to think a lot about curating diverse sets of data. I think the answer is just give people the tools to do it themselves, because the space of harmonization that you have to do for a proper research project is just so large and complex. There's not going to be one good solution. And so I think instead we should flip the question and start thinking about what tools do people need to express the stuff they need to do, right? And then how do they share that? That's really important because that's where you get reproducibility, and that's how the community helps each other to like scale up, right? A very good example of this idea, I think, was expressed in this Pangeo Forge, which if you don't know, there's a good paper. It has many cool pieces. I'm going to highlight the piece where it talks about the creation of a space where a diverse community of recipe contributors can come together to curate data sets. If you don't know what Pangeo Forge is, it is this idea that you can crowdsource complexity necessary for transforming data sets. It's usually marketed as a way to convert your netCDF files to a ZAR store on the cloud. But think of that as input data set, transformation step, output data set, and you have like the start of every research project, right? And they've tried to come up with this idea of a recipe that hides away all the complexity of cloud infrastructure, orchestration, this, that, and tries to give scientists the tools to express the data transformations they want to do, right? It hides all the like infrastructure stuff, but it centers the sciencey stuff and says, we'll handle all of that, you handle the science transformation, and here are some tools for you to express yourself and be very productive quickly. Again, to emphasize, I think in science, identities are fuzzy and they're temporary. At Earthmover, we keep talking about these three little classes of people: data consumers, data refiners, and data producers. And I myself have definitely wandered that space a lot. Sometimes a friend asks for a favor and I suddenly become a data producer. Sometimes I'm just pulling a data set, so I'm a consumer. And sometimes I take a data set, calculate a climatology average, and now I'm a refiner, right? So like, I think most scientists are occupying this space, and we should recognize that and try to build tools that help them. And so I think the commons should encourage the fuzziness of these identities. It should build a space where such people who are interested in doing these things can get together. GitHub is a good model to me. And in this way, I think it really helps build resilience and expand the community. And I think this is really important because sadly, public infrastructure is underfunded today. And like the way to scale that, I think it should just get more people in, right? Because that is the difference between building infrastructure today versus 20 years ago. Today, you can crowdsource, right? We have that technology, and that's what's changed over the last 20 years. So we should take use of it. I didn't have a list of attendees. Maybe I would have worded the title better. But I mean, here's an example that I just recently discovered. This is on the website called Hugging Face. I think machine learning people tend to hang out there. It's a data repository. It centers the data and the community where you can chat. This particular data set is important. This is apparently the only public archive of the German forecast output. From the source, you will get like the last 2 days of data, I think. But this is maintained by a nonprofit called Open Climate Fix, and it's public. People like it. And look, the people are right next to the data. They're chatting about it, getting their questions answered, and thanking people for doing valuable public service. Then entirely independent of the producer of the data, right? So like this energy is out there. And like, I think we should think about how the commons can use it. Google weather events too. I don't have to introduce, very, very common. But here's another one I discovered recently. This is the HER archive, another forecast data set, NOAA's High Resolution Rapid Refresh. This is the University of Utah archive. And they thank the Climate Corporation for providing their archive prior to 2018. Like, some level of collaboration between academic sector, the private sector, and the nonprofit sector is clearly possible. Like, there is energy out there, and I think the Commons needs to harness that in some way. So our charge today is to think about building a geoscience data commons. I think we should center the people more. And so one of the core questions on the website was like, who should be eligible to deposit data in such a resource, and how does that process work? I hope I've shown you 2 examples that expand your mind and who could deposit that data. But I think the real answer is, if you engage with Ostrom's work, is like the answer to such questions should be handled by sub-communities who can self-organize and make this decision for themselves, right? It isn't crazy to me that the climate quality observation people have a different opinion than the weather forecast model people. Right? It would not surprise me. And I think this is what GitHub has done for the open source science software community. it's given a platform or a place where like little sub-communities can just pop up and organize themselves and do what's right for them. And that turns out to be very, very successful. And this is the kind of idea that's kind of animating us. We're trying to build a Ray Lake, and we look to GitHub a lot as a model. And we constantly ask ourselves, like, how do we build tools to let people help themselves rather than just solving the narrow problem that they're expressing to us, right? Like, how do we generalize and how do we give you tools? So, summary, what can we learn from an open science software commons? I think it's that community participation is the most important common pool resource. We must build spaces that get people together. And by people, I mean a very, very broad definition. There's clearly interest and energy in the nonprofit and for-profit sectors that could really help us do a much better job. And as you engage with questions over the next 2 days, I hope you will always ask, how much can we crowdsource here? Right? So, thank you.
All right. Thanks very much, Deepak. All right, to close out today's plenary session, we have Dr. Rahul Ramachandran. Dr. Ramachandran is a distinguished senior research scientist at NASA's Marshall Space Flight Center and leads the interagency implementation of the Advanced Concepts Team Impact. His research interests span a range of topics, including data science, informatics, and AI ML. So with that, I think we'll let you go ahead and talk. Thank you very much for joining us today.
Can you all hear me? Okay, awesome. I guess we love our acronyms at NASA. So I'm going to give you a very opinionated perspective on scaling issue that we have within Earth science, actually all science within NASA. And obviously, my ideas on how we can address some of these scaling issues, talking about technology as a solution, specifically AI, and how we are looking at it. I do want to mention there is, I think Tasha mentioned this about the mindset that already exists in large organizations that's very hard to change, especially around the data management part. I do have one slide for that. It's the culture is very hard to shift in terms of how people have been doing it successfully for so many years, but I think we now have to look at it from a completely different lens. So I show this slide. For us, the data is the center of gravity. Everything centers around the data. You start your research around data. The inner circle is a data lifecycle. So this is NASA's data lifecycle. You'll have a different lifecycle within your system space, right? So for us, it's an instrument is launched. We start getting these bits from space. They have to be converted into some science data product using some standardized algorithm. And then that data is then ingested. We have documentation in terms of metadata and how to use the data correctly. And then that goes into different systems where you can make them discoverable, usable, through distribution access. So that is the internal, the data lifecycle that we have. The blue ribbon is basically all the tools, services, infrastructure that supports both the inner lifecycle, which is the data lifecycle, and the outer circle, which is the research lifecycle, right? That is what your researchers come and do, right? They find the data, they have a research question, they access the data, they do analysis, whatever may be the platform, and then they publish. And that's the whole cycle that goes through. So this is kind of how we look at it, is that the data and the tool infrastructure enable the research, right? And I'll propose a shift to this. So we all know this, right? I think Angel mentioned this in his talk about scale. We're basically dealing with this issue of scale. We're drowning in data, and not just data, information. I don't even know where to find papers these days because it comes at like a million places to access papers. But this is not new. Actually, if you go back and look at the National Academy Sciences report in the 1980s, they were worrying about the same issue. Only thing is the scale was very different. We're looking at terabytes of data, and now it's completely different. So I think the challenge for all of us is like, how do we manage this overwhelming amount of data and then also be able to distill meaningful insights from this archives that we have, right? So just to give you some numbers here, this is just Earth Science. So we are about, I would say about 100 petabytes in our archive. So this is NASA's Earth Science data archive. And within 5 years, it's going to be 600 petabytes. And our budget is not increasing. So the question, is like, how do we manage this, right? It's not a, I like all these things that, groups come up with, like FAIR and, all these requirements. But they have to meet reality somewhere, right? We can't trying to make everything findable, accessible, interoperable, reusable. It's a lot of requirements that you end up putting on the data systems, right? I think it's unrealistic in a lot of ways. So I think this is the question we've been asking, like, how do we improve the research process as well as lower the barriers of entry? I think we've seen this theme mentioned in other talks too, using different approaches. I will posit one approach, obviously based on AI that's happening right now. I think it's time for us to think of it very carefully about it and how we can incorporate this into the both data lifecycle and research lifecycle. I think we are at the right time in terms of capturing the crest of the wave of this technology innovation that is happening, right? So this is just showing the different stages of AI or machine learning, how it's advanced over time, right? We had in 80s, we had expert systems, which were very brittle. Then 80s to 2000s, we were doing machine learning. That's kind of what I learned. You were focusing very much on feature engineering. Then you came up with deep learning neural networks, where you needed massive amounts of labeled data. So you need a lot of labeled data. With compute, you could solve a lot of problems that you couldn't do with traditional machine learning approach. But the major shift that happened was the 2017 with that Google paper, attention is all you need, where this notion of foundation model came into play, where you could give a network the data without needing any labels. And the network would learn on its own through self-supervision. It's not magic. We can get into details of that, how they go about doing it. But the idea that you could basically build a network without needing labeled data, but you still needed a lot of compute. But this idea of foundation model has, we think it can change the paradigm in terms of how we manage our data and also how we can, use our data for analysis. So this is traditionally where we are. We have, our data archive. Each researcher will basically come and grab the data. They will build their training data sets, and then they will build their own machine learning, deep learning model, their own bespoke model, so to speak. And the networks are getting, larger and larger. You need lots more training data. You need lots more compute. Can we shift this paradigm a little bit, right? And this is when we held a workshop in 2022. One of the key things that came out of the workshop report was that the training data is a bottleneck. We need more and more of training data. So with the idea of the foundation models, is we can select data or data sets from our archive, and we build these foundation models using pre-training. And we give these models out as a starting point for people to develop their own models. So then you can do adaptations of these models really quickly. And what it does is it reduces the number of labeled data that you need. It can go from thousands to just hundreds. And also it reduces the compute needs that you have, right? So this is the shift we want to move towards. So, what we envision is, can we, like if we unroll the data lifecycle and we unroll the research life cycle, how can we use these foundation models in these places effectively, right? So we are looking at language models. Can we use language models in terms of data stewardship, data management? Also in terms of analysis, like how can we help user do analysis? It could address some of the accessibility questions that was asked earlier. And then on the downstream side is, can we build these foundation models for our high-value data sets or for thematic areas? and provide those models to our community so that they can use them for their particular applications. So this is our list. This is where we are. We've been working with IBM Research on this. It's been a collaboration. Again, it's an open project. We invite people to join. As you all know, building these foundation models requires a tremendous amount of compute. NASA does not have the compute. We work with other partners to get compute. So the list is, we build a language model focused on science. It's targeting NASA's 5 science mission directorates. We did not build a generative model because of liability issues. We've only built a base decoder model, but we can use the base decoder model for some of our search and discovery applications. We build a foundation model on optical remote sensing data. It's on the harmonized Landsat Sentinel data set. We've been working recently on the weather and climate. We hope to release that within a month or so. And the next one is looking at space weather using our solar data sets. So that's our list of building these foundation models out. I'll show you some examples of how we are trying to use some of these things. And there are better examples than this. This is basically an example of doing extractive search. So where a user can ask a question, we use the encoder model to understand the semantics of the question, and then we can match that semantic to a particular couple of sentences in a paper. So that's an extractive search. It's not a generative search. But the nice thing is you can actually combine it with a generative model to do something called a RAG. So you use this to find paragraphs that match your question. Then you give it to a generative model that can give a better answer using combinations of those extractive paragraphs. So then that way it's grounded. This is another example of using a language model where you are reducing the complexity for end users, right? They can ask questions in more natural way, right? They just ask straight questions. Those questions are then used by the language model to transform into SQL queries at the back end. It can farm those SQL queries to different data sources, pull the results back, and give you the answers back. So this is kind of where things will go in the future. I mentioned the foundation model that we built on the HLS. This is 2 classifiers that were built based on the HLS foundation model. One is looking at burn scars, the other one is looking at flooding. So it's very easy to take that foundation model, do adaptations, and allow flooding and burn scars, and then put it in your different tools for end users to find. So I'm going back to the data lifecycle that I was talking about. So I think what we think that can happen is we not only provide the data, but we also provide these foundation models, not only on the language side to help out on the data lifecycle, but also on our actual data sets, so we can actually enable people to do extract insights from the archives. The figures on the right is basically showing where hopefully the future would be. It's basically, I think this is landing.ai, which is basically a no-code platform to doing machine learning, right? You don't need to even know any programming. You can just give samples to a model, and it will basically learn and give you results that are good enough for you to use for your particular application. So hopefully that's where we will reach in terms of science, where we can actually make it much easier for people to use in terms of complex science data. I think I want to go back to the point that Tasha made in her presentation. For researchers, managing science data is very complicated, right? You are pretty much on this person on the left-hand side. You have your particular project needs. You only care about science. But you have to figure out what is the policy, what are the standards, what are the best practices. And to be honest, it's like a black magic. Nobody knows how to do this. Like, how can we simplify this? And this is something that we've been working on as a side project within our group, is can we come up with this notion of modern scientific data governance framework? The idea here is, we have to align. There are some policies that we have to align with, like there's the Geospatial Data Act, there's Open Data Act. So there are certain policy requirements that we have to follow. Then there are things that come from agency, like SPD 41 policies that you have to follow. And then you have FAIR principles. So how do we take those requirements and put it together in a systematic manner that somebody who wants to, all they care about is managing their data, can get the guidance on how to do it effectively. And this is not at a vague level. So the idea there is that you identify for your particular project what entity you're managing. So that is the figure on the right-hand side, the cube, right? You decide whether for my particular project, I'm interested in managing data, metadata, digital content, code. And you decide for your particular project, what data life cycles are important to you. And once you do that, the framework will basically look at the requirements, implementation procedures to meet those requirements, and also look at, that's the goal we want to get to is automation recommendations. Like, what all can you automate so that you don't have to do these things manually? How do we do the monitoring well so that we know, we are not deviating from the processes that we started out with? We see this with all the time with projects. They start off doing everything right, but after 2 years, you see this drift. There are issues with metadata, the documentation is stale. So how do you figure this out? I hope you guys also talk about this. I think there is a session on the data side that you discuss this. This is available on GitHub if you want to go look at how we are approaching it, and you have recommendations on how we can improve this. That'd be really helpful. So I would put this as a closing thought. I think, especially in terms of AI, I think I found this quote somewhere. I think it's the new technology tends to redefine what we do. I think we've seen that with cloud computing. I think what is interesting is what we initially try to do is fit the tools in the old ways of doing things. But I think it becomes clear after a while that we need to change our existing methods, processes, and maybe even mindsets to adapt to the capabilities of the new tools. I think for AI, it's very much the case here that we need to take a fresh look at how we manage data, how we enable analysis capabilities for our end users here. So with that, I would end here. Thank you so much.
All right, thanks to all of our speakers. If the speakers wouldn't mind coming to the front, we'll have a little session of Q&A, and then we'll move into the coffee break before we go out to breakout sessions. And in the control room, if you could put up the slides for the breakout sessions, it's in kind of the main folder, not the one by day.
Okay, hi. So I really appreciate everyone's talks. I am basically just a geoscientist. And I'm sitting here listening to you guys, and I create data and I use data. And there's this discussion of early career being the people who are really pursuing this. But what do we do then with people like me and people a little bit more senior than me that are not able to keep up with this technological advance in terms of using the cloud? What are we providing people to be able to still think creatively about science and data in this new way? Because I don't feel like that's actually being done very well. Most of the people at my level are like, I just can't do it, so I'll just hire people, but money gets short. My other question is, only one person mentioned funding. And I think one of the things that's missing with open source data and putting things on the cloud and allowing it to be accessible is that the burden of financial support then falls on the researcher creating the data, and funding agencies do not include that in their grants sufficiently. So I just wonder what your thoughts are on those.
To your first question, we've thought a lot about this with CryoCloud. It's really been a question of like, how do we meet people where they are and allow the people who really want to go further to get to the cutting edge of whatever is new, and also support others. So some of the ways that we've done this is like we have a space for MATLAB users to use MATLAB in CryoCloud. At the moment, they just have to bring their own license. But I had a better answer to this just a second ago. I think, so CryoCloud or JupyterHubs or whatever cloud you may be using, for us, it looks exactly like it is on your computer, right? You can use RStudio, you can use MATLAB. It's literally just putting it in a slightly different place. And you do have to change your code for data access, but arguably, like, for example, I do sea surface temperature processing, and I have a processing pipeline that I created during my PhD, and that processing pipeline took weeks to download the data, to process the data, and there was 6 terabytes of data that I stored as intermediary data sets because I couldn't, it's really hard to replicate that, right? Now I've produced that same algorithm in the cloud. It took some time to do that, but now I can process that same image in 1 minute. I don't store any of that. I have, a few gigabytes of data that I store now instead. And that's a huge motivation, right, for any scientist to switch to the cloud. If you have the right tools and you have the right data formats, you can achieve that, right? If you don't, there's, it's somewhere in between that you can achieve that. But like having that incentive of saving, like now I can work for, like I can do the amount of production that 4 scientists can do because I've now switched to the cloud, and that has enabled me to do those things. So A, lowering the learning curve, and B, this incentive of saving time are things that I think are really important for enabling those who already have their processes already set up, right? You don't have to download data for weeks anymore to be able to do your work.
I think maybe for the first question, I think the incentive is on you. I think if you think that learning a new technology gives you a competitive advantage in terms of doing science, it makes you more efficient, I think you'll have to learn it. Maybe ask your students to first learn it and figure out, give you the distilled version of it. I see that at least on the AI space. I'm sure all of you have played around with ChatGPT, and you've kind of seen what it can do, right? It's going to change the way you will approach work in a lot of ways. The funding is a trickier issue. I thought, and I could be wrong, is that instead of in your proposals where you were actually talking about we need infrastructure, we need so many computers, you basically are now looking at cloud computations with the supposed value that you don't need to have system administrators on your team to have, right? I think that is the whole motivation there. So I don't know whether that's true or not. I don't know. No.
I think in terms of the funding side of things, there's a lot of growing pains, obviously, as we switch to this new open science sort of era. And I think a lot of funding agencies are really aware of this and trying to figure out how they're going to support scientists and developers to do this. And so continuing to talk about that with our funding agencies and letting them know where the gaps are, I think is really important. But along those lines, part of the issue is really in the academic incentive system, right? We are not incentivized to comment our code, create something that's reusable, and this is really outdated. And what I've been encouraging and what I think is kind of the answer is that instead of, the tenure review process including impact factor, it starts to include impact. And this incentive system is really not something that I think is making any progress at the moment, but that we can start to make progress in our own institutions.
Yeah, I'll add one small thing on the maintenance of data sets. Right? You referred to being a producer at times. I think this is something the data commons can actually solve for you. It's a centralized place that can gather resources and then distribute it across a very diffuse community that may or may not want to maintain a data set 30 years into the future, right? And I think that's like a core challenge to address is, like I said, the people producing data sets are not just sitting at data centers, right? They're not just sitting at data archive centers. They're sitting everywhere. And like the point of having a centralized place like GitHub is like everyone can come there and put their little thing, and then we can discuss and how you centralize funding for that place, right? And I think this is like a core question that we should engage with. Thanks.
We have all these resources and they're underutilized. How do we know that? How do we know we're not doing as well as we possibly could given the constraints that we have? And so I think one of the ways we get at that is by saying, there's this problem, this person could not do it, but here's some changes that I propose, and look, oh, now they have full utility and they can do it. And I think that, and myself included, I'm throwing myself in as a guilty party, is that we tend not to think like that because that's a very difficult thing to do. But in the end, that's all that matters. And I've been part of lots of programs that produce results that were never, and here's the key word, and I think that my colleague over there talked about it, adoption. Because for anything to be successful, it has to have a sufficient level of adoption to see the results. So how do we get to the quantification, which would lead to the adoption?
Yeah, I think that gets back to my talk about social innovation and community building. I really think a gap where that fits in is, having people in our community that focus on that. And I think that that's a huge deficit in our communities right now, is having people who organize our communities. And, that's not really necessarily what most scientists have strengths in, right? But yeah, that social innovation side.
This is really an answer also to the previous question, but one complaint with the whole open science cloud thing is it's very opt-in. You have to very consciously jump in, right? And the way, one way that I've seen people build on-ramps that seem to be successful is this OpenScapes program that NASA's tried a bunch. And so I know I have interacted with fairly senior professors on the XRA GitHub issue tracker. And, these people exist and people are motivated. And I think we really just need to build on-ramps. And there are models and people are experimenting with these models, building on-ramps and, communicating that those on-ramps are necessary and valuable and should be funded, I think is a key outcome and something that we should push for.
Hi. I think our perspective probably is different one. We are an operational service, and sometimes coming back to my presentation is how to find the balance, the right balance between the dynamicity that is out there, a lot of people doing a lot of things, research things, and to create something which is operational, that is able to deliver different communities, different people, different profiles of people accessing the thing. So for us, this is the real challenge. I mean, how to do this in an effective manner, in a thing that is robust and is able to satisfy many people with different profiles. And this is probably another perspective to the research of a more dynamic community. We say each waiting to do things dynamically with the data, with a lot of ideas, but how to operationalize that for the big amount of raw data that we want to offer, I think is another thing that people need to understand. And this is something that sometimes we have this problem, is people out there asking us, oh, this is not effective enough. It's not we want to have more data, more the different, and it's difficult for us. This take me to the funding thing, is how to do more with the same resources that you have. I think this is another question we need to ask, because one thing is the idea, and the other thing is the implementation. So it's, yeah.
I think I'd add one comment on the community building part of it. I think my only concern there is, we have to deal with something called authoritative data sources, right? When data gets replicated across different community groups, then we run into issues of variations that people refer to that may or may not be the right one in terms of lineage. So there are all these little things that have to be thought through in terms of governance part of that.
All right, I'm going to give 5 more minutes for questions, and I get her hand up here, and then I'll move around the room as quick as I can, and then we have breakouts where we can keep the discussion going. So,
awesome, great. Thank you so much. Really fantastic talks today. So I had a question about the role of traditional HPC systems here. So, for example, for CryoCloud, you mentioned cloud computing as a vehicle for open science. But from my naive perspective, HPC and cloud computing are very similar. If the issue is access, you have to put some limits to the access you give, for example, for CryoCloud, so that you don't have Bitcoin mining going on in your JupyterHub. So yeah, so what's the role of traditional HPC systems here? If by open science we mean like JupyterHub, or is that like just the infrastructure, including the commercial cloud computing platforms?
That's a question that is actively being engaged right now, HPC plus cloud. Honestly, my perspective is that we should be able to utilize as many resources as we can. And HPC in a lot of spaces is cheaper. I mean, depending, like CryoCloud sits on top of AWS. So people have access to these supercomputers. How can we link our supercomputers to cloud more seamlessly so that we can access those and potentially share those resources a little better? We do limit who has access to CryoCloud, but for us, our priority is our community. So we're not preventing access to anybody in our community who's at the moment a cryosphere researcher. So we're monitoring that, but it's meant to be a socialized system, and it's different for each community. But I think that this sort of social system is what's really important, where you have people who can pay, contributing funds, and people who can't, being able to still access those resources, and we limit the resources to the extent that makes it very cheap for people to compute in the cloud. Like we provide all of our users access to a 32 gigabyte computer or 32 gigabytes of RAM. So there's cost monitoring that can happen there, and there's ways to make sure that we're not spending beyond what people are actually using, because we're actually finding a lot of our users are using more or requesting more resources than they actually use. So like figuring out how we limit our costs is going to be really important. And we are already doing that in a lot of ways to make it very cheap.
Yeah, I really like your point. I think HPC and cloud are very similar in that they're fairly complicated compute infrastructure, and yet NCAR knows how to onboard hundreds of people every year onto its HPC system and does a good job at it, right? And so I think there's clearly something that we could learn there. One could be make the HPC look like cloud, so JupyterHub looks the same everywhere. But maybe there are other interfaces that can carry over and kind of make the two look very similar and just kind of build that on-ramp. Because NCAR knows how to onboard people onto a supercomputer. That's a skill. How do we use that?
So just go ahead and talk.
So now we're getting into the discussion that I find very interesting. When you talked about depletable resources and common pooled resources, funding is a depletable resource. The funding to pay for the storage or the compute in the cloud is a depletable resource. So how does that interact with the idea of a commons and being inclusive? And somebody asked, who decides who gets to put data into the commons? Because the storage is a depletable resource, even though the data itself really isn't.
Not an expert, but I think Elinor Ostrom's idea is to let the community decide amongst itself, and that's when you have skin in the game, and so you are incentivized to make choices that work for you. And so that was kind of the point that I was trying to get to. Instead of, a collection of people, N people in a room, chosen somehow making this decision, how can we decentralize this? And I think that's the takeaway I took from Elinor Ostrom's work. And that's how she studied systems where people in Switzerland manage common meadows. That is a depletable resource, and yet they get it to work. And there's all of these real-world examples of people managing depletable resources and making it work. And there are possibly models there.
I can just say from CryoCloud, the way that we manage this resource is to, like I said, a social system. So if you have it, you can request it, then you contribute. And so each science team, for instance, that comes in, we say, hey, can you provide funds? And that actually helps to cover, more than just the science team and also development. But this shared resource model is how we've solved that. But that's just our group.
But that's a subcommunity solving the
Mm-hmm.
Okay, I think Brian, you had your hand up. He'll be the last question. And then I'm going to have those.
So, a complaint and a question. The complaint is, I think one of the worst terms in all of technology or cyber infrastructure is cloud. I think I've heard us use it in 4 completely orthogonal ways. Sometimes as hardware, sometimes it's a set of services. So we should be really careful when we say the cloud, because I think everybody means that or uses it with very different inflections, which can make it difficult for people to track. Anyway, off my soapbox. One question I have is, maybe following this, is I often worry about data commons as potentially causing issues in equity, right? Because who's in the commons and who's not in the commons. So I'd be curious of, what you see in terms of, is it a big problem? And since I think no one maybe really mentioned it, one of the things I work with a lot is data portability. And if I have my commons and you have your commons, how do we work across the oceans? And is that something that helps here, or is that something that's really irrelevant?
So when we started looking to move towards the cloud in a systematic way, this is like many years back, we made a concerted effort to work with other federal agencies, Chet would know, with NOAA, USGS. So any earth science data, we wanted to be co-located in US West to Oregon region, I forget where, so that, those major data sets that the geoscience community needs, you can access it without having to move the data out. So my hope is that you have the centralized, as I think that was shown in the diagram, that you have the centralized repositories that are the authoritative sources, and you can have your geocommons which it's basically linking back to the data, right? It's not having to replicate everything. You can do access analysis on the data that's there without having to make hundreds of copies. If you're making hundreds of copies, then we've basically gone back to the same problem, but in a different infrastructure altogether.
Again, in our side, this is a different problem. I mean, we understand that we need to provide to all these people that all the data come. The problem is that this is a public service, what we offer at least, and the public is not always polite, I will say. So in an ideal world, everything should be fantastic. We can share, we can open we can give you these resources, and you. The problem is that the reality is not like that. And when you try to do something nice, you need to consider what is going to happen, because you are going to have threats. And how to manage this for us, at least, is the complexity of these data commons. You can have very nice ideas to offer things. How these people will react and how we'll use these resources is when the discussion starts. I mean, it's when things are not so easy.
Quickly have those whose names are in bold come down to the front. So we're going to get started here and just walk through some of the high-level takeaways from the breakouts. And I'm glad everybody's networking and talking. It's great. So Egg Belly, Mesa Lab 680, either you're up or Riley's up, but here are the... Okay. And you can keep it pretty tight. Just summarize what's on the slide. We're going to try to keep this as brief as possible. It's up there. Don't worry, they're on. Yeah. Something.
Okay, so Riley didn't leave me hanging, so that's good. Does this work? Okay, good. So well, one of the key points was there are still people, at least within our group, we were saying there are still people missing from the table, i.e. we had researchers, we had people use the data, we had analysts analyze the data, et cetera, but there were some people from that equation that we talked about earlier in the discussion sessions that were missing. We also talked about centralization versus maintaining domain-specific repositories. Giving people incentives to produce great data products. So that is what was the term? Social innovation, and that is being able to, if somebody publishes a great data set or it contributes to something like the data commons, how do you acknowledge and recognize them beyond just DOIs? Funding agencies need to support infrastructure and maintenance. Funding agencies typically look at the, I guess how people say it, the shiny new product, but then what happens when your product is, so ubiquitous, it's just like part of the furniture. Everybody uses this data set, and then the funding agency says, yeah, you're on your own now. So, I think some people were talking about the solutions, or not solutions, but some of the areas where foundations like Bezos Foundation, even though it's Bezos, but we'll put that aside. Bezos Foundation, other funds can come in to fill that gap, but that's a huge gap that the funding agencies sort of leave the, ubiquitous sort of mature products just kind of hanging. Research pipelines should be more integrated was another point. And then lastly, need domain expertise in the loop, which is people documentation adjacent to the data. So it's not just having the data sets there, but also having things like, not just saying, here's the data, you're on your own, but having Jupyter notebooks and all kinds of things sort of packaged and ready for use by the end users. All right, thank you.
Okay, this is the Damon room.
Thanks, Doug. So let's see. We had a lot of thoughts here, and I think we've somewhat collected these into a cohesive set of statements. On-ramping, we think, is really important for the success of a data commons. We need to recognize that there's different needs, early career and late career folks, and a variety of other members that might participate or become end users of a data commons. Don't want to leave anyone behind. Need to focus on the people and recognize that the end user community may be far more diverse than it has been historically. Second bullet's really kind of related. Who is the community? Will a data commons be defined by the end goal community or the type of data that we store? Fair access opens doors to broader access, non-scientists or maybe cross-disciplinary scientists. So how do we address issues such as scalability? And I think there's some importance around defining boundaries for the usage, making sure we have good metrics, and implications for domain-specific data formats and APIs. And then I think echoing something that Abigail stated, the NSF 3 to 5 year funding model was really not the right one for providing persistent community services. So how do we build communities that can sustain these efforts and ensure that they are designed in ways that allow them to be migrated elsewhere when grants expire, for example. Okay.
Okay, thanks, John. You can leave that open.
Mine is yours.
Yeah, it's not mine either. Okay, Chapman.
Okay, well, we were a loquacious bunch. And we came up with like 8 things, but they could have been 18 things. We spent like a good part of like the first bit just even trying to define what a data commons was. If you do a search on it, you couldn't find what it was. So one of them was connecting data to the community. So that speaks to one of the previous, the Damon room, break room, where they said it's all about the people. Marketing was one way to bring the data to the people. So advertising, marketing yourself, be shamelessly promoting yourself to the community groups that you want to entice, that you want to bring in. The other concept was adoption, making sure that you get buy-in through kick-ass user experience. So having a really good UI and UX. It's a really good user experience. So when people come in, they're enticed and they want to see what you have to offer. The other thing was onboarding, which is also part of adoption, but it's onboarding and buy-in via training and skill development. And that brings us to a challenge. That challenge being giving people the tools to build their own data commons. So instead of being dictated to us, we could also have the power and the tools to also create our own, and then maybe have a spin-off and then also be able to service our communities better through that knowledge sharing. Science gateways was also mentioned, building and sharing workflows. So when you understand the data and the values that you're getting from when you're producing a query and you get results, you want to understand that the results that you're getting are robust, they're trustworthy, you can use them in your analysis and they won't come back to bite you. There was a challenge, is scoping and scaling data down to useful information, and that went to one of the plenary speakers from the ECMWF, where he was talking about going from petabytes to kilobytes. Petabytes is unusable to the end user. Kilobytes, I can visualize that. Pathfinders was a concept and a term that was bandied about quite a bit. It's a really nice term. Platforms where sub-communities can form and collaborate, and that also speaks to giving people the tools and empowering them to build their own data commons. Another concept was data commons that were interoperable across agencies, and this is to be able to access data from multiple sources. Not just within NCAR, so that we're not siloed, but we can also access data through NASA, through NOAA, through other agencies, potentially through Europe, ECMWF type of data. And so that comes into cost sharing and crowdsourcing. So the cost sharing, maybe that would be a funding opportunity or a saving funds on some level. And then we had some sort of subtopics that were related to number 7, and that was data portability. So that interoperability concept, as well as data control. So supporting a governance structure that respects data sovereignty. And this goes to the CARE principles, which speaks to sort of the needs of first tribal nations people, but which can also be used to define other communities, not just that community. And a challenge, but also, it's a challenge, but it's not a warning, but it comes down to sustainability. So you build this data commons and it's got a kick-ass UI, UX, and people come in and they're using it and it's great. But then what happens in 5 years? Is it still sustainable? Like, is it still a sustainable model? Are people still using it? What happens 10 years down the road? So you have to kind of think in the future of how to maintain the data commons that you have into the future such that it's a sustainable model and then it feeds the user community. And then I don't know if I forgot anything, but Joseph, you're welcome to. No. Okay. So.
All right, thanks, Jackie. Okay, main seminar room. I think this is Tegan. So MSR is main seminar room, for those who didn't know. Sorry for the acronyms.
Okay, thanks. I think we maybe updated our slides a little bit late, but so one challenge that we were talking about within our group was data discovery and access, and that we really wanted to emphasize training to use the data and to have training available to like a wide variety of people. We also talked a lot about having a user-friendly search interface, and that would be important for finding data sets. We also talked about focusing on the needs of users and expanding data access beyond existing NCAR user community. And then one point that we talked about as well was data governance. And so we were talking about trying to balance both democratizing data governance and maintaining data integrity and fidelity at the same time. We also mentioned that all of these different things need funding. And then there were a couple points about kind of the risk of using cloud infrastructure, and that there's always like some risk about things potentially like not being supported in the future. So we were just trying to kind of brainstorm like what some potential things to think about were in the future.
Okay, library A.
Thank you. So we also talked about onboarding a lot when you have busy scientists or even at the level of institutions that you really need to give them help with focused trainings, with hack weeks, ways to get those communities to interact, to share the knowledge with each other, give them worked example use cases on your resource, showing them step by step how to do something. And we need for these systems to focus on community developed solutions that address real science needs. People need to know how to solve the problem they have right now, not invest weeks in learning something new that might potentially help them in the future. You want to build these things around existing knowledge, give them what they're used to looking at, what they're used to working with. We did talk about how even though the idea of one perfect solution, one perfect commons is attractive, it is not practical. We need communities to work together to converge around standards that work for their data and their questions in their ways. And then with that convergence, it becomes more tractable to do that crosswalking and creation of interoperability tools to work across those different communities. We did have a lot of success stories. Even the ones that were not perfect did move work forward. A bunch of them are listed there. But within that, there's recognition that plenty of gaps also exist. We noted those in more full detail. But I think there may be something to learn from looking at those success stories. They're very different in the kinds of things they are and the kinds of success they have. There might be something worth looking at and learning from those. Thank you.
Thanks, Karen. Library B. Thanks for scrambling to write these things in, too.
We got one missing, too. Yeah. Oh, cool. Cool.
Yeah, we can go ahead. Okay, so one theme that came up during different prompts at our discussions were the emphasis on education and training and some best practices for the community to adhere to, and how we can ensure fair and equitable access for all users, how we can make sure that we have a system in place and the educational materials with it in place so that like everyone know what to do and what are the best practices and how we can incentivize them then to adhere to these best practices. We talked about how education and training is different because in some sense we can have educated users who do not adhere to best practices. So how we can make sure that we are incentivizing adherence to these best practices. Also, we talked about how we can have a standardized metadata and how we can have community developed standards for metadata, and how the different communities have different types of metadata that they want. So how we can have those discussions between these different communities, weather community, climate community, oceanography communities. The other one that we talked about was that how large language models can be used for to provide some sort of a user interface for data for discovering data. So, for example, as a user, I'll go in some interface and just type in, give me the temperature data for this point in the world for this period of time, and without me having to know the name of the data set, it will give me, okay, these are the possible options for you to use in your data, and then how we can ensure if I am a professor at the university, I have some standards that I can adhere to so that my data is discoverable. And then we also talked about how most of our university professors and also university students mentioned the importance of JupyterHub for their training and their development of their courses. They mentioned that they are using JupyterHub. We also talked about Google Colab to some degree, but one important thing is that it seems like there was most of our professors and university faculty were using the locally hosted JupyterHubs for the majority of their classroom activities. We also shared some resources for the university professors to get access to JupyterHubs and some allocations for their courses. We talked about Access, Anchor HPC. Copernicus also provides some resources for professors. We talked about Jetstream. And then finally, and I think the most important point that we had was how we can build this trust as a community to create this data commons and move forward our field, and how we can have discoverable and findable data, building the trust as a community, and how we can adhere to that. So I guess that was the summary.
Yeah, I think the only other thing that I'll add on to this is around like education and training, and I think communicating, as you know, everybody here, it's the communication that we're doing here is help driving all of this forward. And I think that communication, even with your small teams up to a larger level, is really required to make any kind of progress here, to make sure that we're working together, that I'm not doing the same thing that Negan's doing, but in two completely different ways. So just working together and communicating to make sure that we're not duplicating efforts.
Right. Thank you. Yep. Okay, Library C.
It's hard to be the last one, and a lot of things that has already been said. Right. Kevin had done a lot of note taking, so a lot of things to come from Kevin, and I just like put some titles for each part of it. One is that really some of the ongoing development from NASA and other different groups, really that leveraging those natural language processing or large language models for data discovery, as well as how to help users use those data. I think that has been mentioned from last group as well. I think one of the major challenge also mentioned by multiple groups is the unramping or the educating the workforce, not just for the future workforce, but also the current workforce, like how to upskilling or reskill those current workforce with all those things that can be or will be included in data commons. And there's nobody teaching you how to contribute to a repository in GitHub in school. So how can we address that? And a lot of the things, collaborating and sharing, contributing to the open source projects, and some social technical consideration, including the resources, where does those resources come from, and how can we really equitably allocate those resources in the context of data commons, and how people are using that, and also incentivizing the contribution or contributing to the data commons, not just as a taking things, but also contributing back to the entire community as well. And one thing that we also mentioned at the end is like, what's our North Star for our data commons, like defining what do we want to achieve through a data commons or a collection of data commons. Is that adoption by the community and coalition of the communities under the data commons really move the community forward and move the infrastructure and data forward. Anything you want to add?
No, I think we got it.
Okay. Thanks to all of the note takers and moderators. We'll give you and that concludes today. I think tomorrow we start at 8:30 with plenary sessions here. So we're going to have a big day tomorrow. I appreciate your patience and contributions, and I look forward to more discussions tomorrow. Thanks, everybody. And the bus will depart at 6 p.m. For those riding the bus.